Hello everyone, and welcome to multiplication property of exponents. What we're going to be doing today is talking about all the different rules and things that exponents do when you're multiplying the bases together. Now, as we went over in class, exponents multiply the base by themselves. Base by themselves. Which means that if you have x cubed, what you really have is x times x times x. Okay, the cube, the 3, means that that's how many times the base is being multiplied by itself. Same thing with numbers. If I have 3 squared, that means I have 3 times 3, which in this case would be 9. Okay, so throughout this entire PowerPoint, keep that in mind. If you have an exponent, that means you are multiplying the base by itself that many times. Okay, so when we come down here to multiplying monomials together, it's the same principle. Whenever you have the same base, then you can add the exponents together. Okay, so to take this example, and I bring it over here, if I have b cubed, that means I have 3 b's. So 1, 2, 3 times b to the 5th power. So it means I have 5 b's. 1, 2, 3, 4, 5. And then you can just count them all up, and you have 1, 2, 3, 4, 5, 6, 7, 8 b's total. All right, that's where b to the 8 comes from. Now, you can only do this when the bases are the same. So if the bases aren't the same, you can't add the exponents. But as long as you are multiplying the bases together, then you're going to add your exponents together. So, coming down to this first problem. I have a 6. I have 6n cubed times 2n to the 7th. Okay, so my numbers will multiply like normal. The numbers will always behave normally. So this is 6 times 2. I'll actually break it up like this. So 6 times 2. And then I have n cubed times n to the 7th. All right. And you can write it like this because remember, multiplication is commutative, which means we can move things around. So now I have 12 n. I can add my exponents. N to the 10. Now I'm going to come over here to letter B. And right now, just by looking at it, I see we have a number and then 2 different variables. But the rules stay the same. So I'm going to pull my numbers out front. So 3 times, and don't forget there's like a 1 right there. So 3 times 1. And then I'm going to pull my p's together. So p times p3, or p cubed. And then t cubed times t to the 4th. Okay. And all I did was rewrite this so that my like terms are right next to each other. Okay. Once you get the hang of it and once you start seeing the patterns, you don't have to rewrite it like this. But at least for this PowerPoint, I'm going to keep writing it like this so that we can get the feel for it. So 3 times 1, that's 3. Then you come over here to the p's. Now remember, whenever you don't see the exponent, that means there's a 1 right there. So I'm adding my exponents together because I have 1 p and I have 3 p's over here. So now I have 4 p's. And then t, same thing, I'm going to add my exponents, t to the 7th. And there you have it. Okay, video is going to pause. What I want you to do is do these 2. If you need to separate out your variables, like in this one over here, go for it. Otherwise, good luck. When the video plays again, you'll see the answers. And here are your answers. All right. Bit of a side note on this one. You may have noticed that you have the same variables in both sets of parentheses, in both terms. So I have an r in the first term, and I have an r in the second term. And same thing with the x's and the t's. If ever you have, let's just say we had a y in this back term, and there's no y up front, well then it would just, here I'll use a different color so you can see this. If I had a y in the back, or any variable in one term that's not in the other, it just kind of tags along to the side because there's nothing to combine it with. The only thing that you would need to make sure of is that you write your variables in the proper order. Ooh, which actually I did not do for this one. So it should be 24 r to the 6, t to the 4, x to the 4. Because remember, your variables go in alphabetical order. Now, so in all of those problems, you had one variable with one exponent. And you may have been multiplying bases together, but still it was one variable with one exponent. Well, what happens when you have multiple exponents? Okay, this is called power of a power. Now, as you can see down here with this first example, I have 3 squared. Now, think back to our definition of exponents. When you have an exponent, that means you're multiplying the base that many times. So, right now, my base is actually 3 squared, and my exponent is 4. Now, we will eventually get to the squared part, but when you're dealing with exponents, when you're dealing with multiple exponents, you start with the outside and you multiply in. What that means is I have 3 squared to the 4th power. And it's a little hard to explain in words, but you can see it clearly illustrated right here, where you have 4 sets of 3 squared. And then when you multiply your bases across, the rules still apply. You can add your exponents, so that's 2 plus 2 plus 2 plus 2, which ends up being 8. Well, if you notice, going back to our original problem, 3 squared to the 4th power, 2 times 4 is also 8. Okay, so instead of expanding your problem out like this illustration does, whenever you have a power to a power, you can multiply your exponents together, and that'll give you the same answer. Okay, look over here at example number 2. Again, same thing. You have r to the 4th power, all to the 3rd power, all cubed. So I can expand it out to r to the 4th, r to the 4th, r to the 4th. And when I add my exponents, 4 plus 4 plus 4 is 12. Well, 4 times 3 is also 12. So by multiplying my exponents together, you get the same answer. Let's practice. Now this one obviously has a lot of different variables, or a lot of different exponents. Don't freak out. You start with the outside and you come in. Okay, so what I'm going to do is I'm going to multiply my exponents together, and then we'll expand it out to see if the answers match. So right now I have 4 times 2, so I'll write it down here. 2 cubed squared to the 4th. All right, so 4 times 2 gives me 2 cubed to the 8th power, and then 8 times 3 gives me 2 to the 24th power. Now, since this is a massive exponent, I'm not going to actually multiply 2 out, or actually give the 2 the 24th power, just because it's so big. And you can do this when you have really big exponents. You can just leave it as the number to the power of the exponent. All right, now I'm going to change colors, and let's expand this and see if we get the same answer. So again, outside coming in, which means I have 4 sets of 2 cubed squared. So that's 2 cubed squared times 2 cubed. Okay, now my base is going to remain the same, and I'm just going to add up my exponents. Base stays the same, you're adding your exponents. So I now have 2 cubed, because that's my base, that's what's inside the parentheses, to the 2 plus 2 plus 2 plus 2. Okay, so far so good. All right, now that means I have 8 of this inside thing. Okay, so I have 8 sets of 2 to the 3rd. All right, there we have it. 8 sets of 2 cubed. My base stays the same, and I can just add up all the exponents, which we know is 3 times 8, which gives us 24, and it checks out again. Our answer is A. So now you know, no matter how many exponents you have, as long as it's from a power to a power, you start on the outside and you multiply in. The same logic works if you have multiple variables inside the parentheses. Okay? Because remember, an exponent is how many times you're multiplying the base by itself. So in this example, I have 2yz squared all cubed. So that means I'm multiplying 2 by itself 3 times, y by itself 3 times, and then z squared by itself 3 times, which you can see illustrated over here. So I have 3 2's, 3 y's, and 3 z squares. In which case, you get 2 cubed, y cubed, and then z6. Now in this case, since the base and the exponent are small enough, you can simplify that out and just get 8. So whenever you're doing this, remember the numbers will always behave normally. In this case, whenever you have a number to a power, you usually simplify that down to get the simplified number. So your numbers will always behave normally, and then your exponents multiply. So to write this out over here so you can see it clearly, I have 2yz squared cubed. Okay, so to multiply this in, I have 2 cubed. Y has a power of 1. So 3 times 1 is y to the cubed. And then 3 times 2 is z6. And you get the exact same thing. Now, with all of these different variations, how do you know when you're done with the problem, and how do you know if there's not still something else you have to do? Okay, here are your tips and tricks. I'd advise you write this down. First one is every variable appears exactly once. Okay, look back at the problems we did. There's only one instance of x, one instance of y, one instance of z. Okay, so every variable is only appearing once. If you have more than one of the same variable, you need to simplify that down further. All right, there are no powers of powers. So you can't have y squared cubed and say that's completely simplified. You need to multiply those two things together and get y6, y to the power of 6. And then all fractions are in their simplest forms. All fractions, all numbers. So if you have 2 cubed, you can simplify that to 8. All right, if you have 4 over 2, you can simplify that down to 2. All right, so simplify down as far as you possibly can. Now this problem, don't get scared by it, looks way more scary than it actually is because there's a lot of variables. Take it one step at a time and it's a lot easier. My tip for you is to do this first parentheses first and then the second parentheses and keep them separated like that for the first step. All right, the video is going to pause. Try to figure it out on your own, and then when it plays again, I'll walk you through it and you can compare my process to yours. Okay, here we go. So first off, I'm doing this first parentheses. So I'm going to distribute my exponent to each of the pieces. So that means I have 1/2 cubed, a squared cubed, and b squared cubed. No, you don't have to write it out exactly like this, but I'm distributing it that way you can see what's going on. Now when you have a fraction, the exponent goes to both the numerator and the denominator. So that means I have 1 cubed over 2 cubed. I'm going to multiply my exponents together, so now I have a to the 6th, and then again over here, and I have b to the 6th. Okay, I can simplify this fraction a little further, and now I have, well, 1 cubed is 1, 2 cubed is 8. So now this is the simplified part of the first half of the problem. I'll change colors. Now let's do the back parentheses. Work from the outside in. So right now my base is everything on the inside. So I'm only going to multiply the 2 to that 2, which means I have a negative 4b to the 4th power. Now I'm going to multiply this exponent in, or distribute this exponent in, to each of the individual pieces, which means I have negative 4 to the 4th power, b to the 4th power. Careful here, that's a negative 4 to the 4th power. So what that is, that's negative 4 times negative 4 times negative 4 times negative 4. Okay? The negative sign is inside the parentheses, so don't forget it. That means we have 16, 16, and then 16 times 16 is 256. So times 256. B to the 4th. Okay, now we combine like terms like we always do. So I have two numbers, so now I have 256 divided by 8, because what that is that's 1/8 times 256. Whenever you're multiplying a whole number by a fraction, the whole number goes on top. So 1 times 256, that's how we get this fraction. There's only an a in the first term, so a to the 6 just comes down. I have b to the 6th times b to the 4th, like that. Now, in order for this to be fully simplified, you need to combine both you need to simplify your fraction and your b's. 256 divided by 8 ends up being 32. Then we have a to the 6, b to the 10. And that's your answer. Now, when you're doing these things, the two things that are probably going to trip you up the most are knowing your rules and then the big numbers. Okay? So what you need to do, make sure you practice the rules. What do you do if you're multiplying bases? What do you do if you have a power to a power? Okay, what happens when the fraction has the exponent? Okay, there's a lot of little pieces that go on. They're simple pieces, but there are a few of them. So make sure you make a list, make flashcards, whatever you gotta do, and know your rules. The second thing, don't get scared of big numbers. Okay, we're dealing with exponents. Big numbers come with the territory. Stay calm. Be very careful on your math mistakes. Be very careful with your math that you don't make mistakes. But if you work calmly and carefully, it's a step-by-step process. All right, well, that is it. I will see you in class.